Okay, good evening, everyone. Like I have just said, today we are just going to do hands-on. Last week we had already looked at embeddings, and then embeddings. We had looked at embeddings, and we had looked at Pinecone vector database. So today we are going to pull all of those together and build a RAG. That is what we want to do today, and I'm going to essentially just spend this hour and a half or two to do a RAG from scratch. We'll start with simple implementation with Python, and then we'll do a more, not compl I won't say complicated, but an involved implementation using a fast API with fast API endpoints so that it's easy for for you to interact. And then after that, I'll see if there's enough time, I'll do that with JavaScript as well. So I'm going to use the tools I'll be using. I'll be using a Jupyter notebook, right? Just for the first one. Okay. And then um, just for the simple use case, I'll use a Jupyter notebook. But after that, um, for the fast API one where I'll be doing a backend, I'll go to VS Code and I will do it there. I will actually create a GitHub repo and I'll do it using github.dev. Actually, I won't use VS Code. I'll just use github.dev and code it in a GitHub code editor. So this is just to allow us to see it work, right? And then thereafter, we can try it out. I'll pull it into a VPS and run it there so we can see how it looks like or what it looks like. Okay, so let's start. Right, so simple implementation with Colab. So this shouldn't be really difficult to understand. This is kind of a warm-up, so think of it like a warm-up. You're warming up your brain so that everyone understands the basic principles of a RAG. And just to help with that thought process, I'm going to take this here, right? These are the basic principles for a RAG, right? So we start with this. We chunk data, we generate embeddings, we store in a vector DB, we run a user query, we query the vector DB, we feed it into the LLM, right? Those are the steps. Even though I will not do all of those steps immediately, right? But those are the steps. Okay. Um, so I'll spend a little bit of time just to make this markdown look nice. That might not be a very good use of the time, but um, okay. So, all right. So this is going to be a reference point for us. So a simple implementation. So starting with a simple implementation, we will um, so we start off first by so the plan is this, right? So this is my plan because it's always a good idea to plan what tools do you want to use. Now, this is opportunity for me to also showcase the Facebook AI, um, you know, database library, the FICE, right? The vector database library. So this is the plan. The plan is we simply will start with a simple representing documents. Okay, so use FAISS for the vector database. Then um, we just use a simple list of strings as the documents. Again, this is, like I said, a warm up so that people don't I don't want people to focus on too many things at once. So we are going to start with just focusing on the bare bones first. Then we will use um, Hugging Face sentence transformer, right, for embedding. So you always have to choose what you want to use for your embedding. Okay. I could also do this with Pinecone, by the way, which I did sometime already. I did it in the last class where I basically just did embeddings with Pinecone. Or maybe that's what I should do first of all. So let's use let's use Pinecone first. Since we already did that last week, so it's going to be easy. So minimize the moving parts. Right. So we will simply use Pinecone for the vector database. Use a simple list of strings as our um, documents that we want to put in the vector database. Then we use Hugging Face sentence transformer for embedding, right? So this becomes very simple. So let me start with very basic stuff. So the first thing is um, im import. So let's import the sentence transformers. Okay, we're going to run this first and see if we already have sentence transformers installed in this runtime. It does look like it's already installed, so that's okay. Um, let's also import Pinecone, and then let's also import NumPy. The reason why we don't specifically need NumPy, but the reason why we're importing NumPy is because we need um we need NumPy to calculate the similarity, you know, the embedding similarity. So we can use cosine, even though that's not really very necessary, but um so Pinecone doesn't come with the it doesn't come with the runtime, so we have to install it. Pip install Pinecone, like we did last week. So that's going to quickly install Pinecone for us. Okay, I have to restart session and just run all. Okay, so this just confirms that our imports are okay. Okay. So first thing is documents. Okay. Okay, first thing is embedding model, right? Um, using the sentence transformers. So this is pretty easy. We can decide which one we want to use, right? So normally if you are not really sure what to use, you can go to Hugging Face and just go look for sentence transformers in their list. So I'm already logged in. You go to models and then you can just if you click on this is kind of a search filter that is basically going to, limit this. So we can have sentence transformers all mini LM. Some of this we have to figure out whether they are available or whether you have to pay for them. But whatever is the case, it's good to check. So this is how you copy its the name of the model here. Then I can go back. So I'm going to keep two of these. I could actually just do two of them. But let me keep these two just so I have two, the Google embedding Gemma and then the sentence transformer all mini LM L6V2, which that's this one, the second one, sentence transformers all mini LM L6V2. So we can use any of these two. Now, so that's the first thing. Then second thing is we want to, yeah, when I'm doing the JavaScript, I will also show how you can install. But I think you just do npm. Yeah, okay. So um right. So the second thing you want to do is let's simulate our documents. So we can just simulate our documents by typing a bunch of strings. So for now, these are the strings that we want to use, okay, to be our documents. Then they don't necessarily need to be in this order. You could set up your documents first or do your embedding model. Eventually, when we are going to do the bigger one, we'll see how it doesn't really matter, right? The sequence. Now, um, the simple implementation of this is we already have these documents as strings in a list. So the sentence, most of these embedding models are designed to accept a list of strings, right? And either a single string, like in this case, or a list of strings. Or even in this sentence transformer, you can even put an ND array, which is a NumPy array, right? A multi-dimensional NumPy array, which is basically a vector. So you could actually put another vector in, which contains numbers. So they make it that flexible, right? So if we run each of these at each step, so let's use the all mini, right? So it's getting loaded here and loading is done. Then these are documents. So the first thing we do is to do the embeddings. So we use the model encode to encode these sentences. Let's assume for now these are documents into embeddings. So you can now see that the sentences become embeddings. The embeddings are a vector of floating point numbers, right? And that's basically what it is. So that's it, right? Now, the next thing is you can now store these embeddings, okay, in your Pinecone database. So that's the next step, right? Um, so of course I should have added this as a comment here. And then so number 4 is store embeddings in Pinecone vector database. Okay, so remember with Pinecone, I have to create an index first, right? So I have to create an index, and then that index I can use. Now you can use one index for multiple projects, but it's probably not a good idea. So this is the index we created last time when we were doing embedding tests, right? Just trying to figure out how embeddings work. So now I want to create another index just for the RAG. As I can call it a small RAG, right? So I can create an index. I'll call it a small RAG. Small RAG. And yeah, so again, this whole thing about should I use the hosted models, the hosted embedded embedding models, or should I use my own? So I'm still going to go with custom, right? But the beauty of using this is I wouldn't need to do embedding, but then that won't show us the whole thing. So I'm going to use custom settings. And because I'm using custom settings, I need to go check out what this embedding model is going to give me. So note that if I use this embedding model and I configure my vector database, right? If I switch to a different embedding model, it may not be compatible with that vector index that I created simply because of these configurations, assuming they are not the same. So sentence transformers, all mini LM L6 V2. If I look at this, right, you can see information about it. Embedding Gemma has 0.3 billion parameters, so that's about 300 million. So it's definitely a bigger model than this one that has 22.7 million parameters, right? So, but this has been downloaded more times. This has been downloaded 148 million times, while this has been downloaded just 608,000 times. So this is probably a newer model. You can see updated September 25th. This is March 6th. Okay, so let's go here. So here you can see that this is a sentence transformer model. It is a 384 dimensional dense vector. So the keywords here, 384 dimensions, and it's also a dense vector. So it's very important to take note of that. Now, so when I'm setting up my pinecone index for this, it's a dense, so I have to pick dense. And then the dimension is what, 384, right? That's the number of, that's the size of the vector, the embedding vector. I can choose to go with either cosine or dot product or whatever, but let's just choose cosine. And capacity mode serverless. So the rest of it I'll just leave as is. And I'll click on the create index. So this index has been created, right? So I can now use this index. So to use the index, I want to create um, two functions in Python to help me do this. right? So I'll I'll create function called store in DB. So it's going to store in DB. And so here I'd already encoded the documents, which is interesting. But this encoding will become part of, what I want to store. So if you're storing in a vector, remember you can use the you have to make metadata, right? So what do you use as your metadata? It is the actual sentences that you use, as your metadata. So so to do this, right, I will uh, first of all create a record. So there is a thing called, so let's say documents, and this should be, let's just say a list of strings, right? We could also do the embedding as well. So let's have the embeddings as also another list of um typically it should be a list of arrays. So we can now do a zip, right? Records. So record is an empty list. So we can now do for documents. For doc, okay, so let's say doc and embedding in zip. So I'm going to zip the I'm going to zip the documents and embeddings and then extract each of them. And I can now create this. So the ID will be a string. Um, well, so we can go with this. This is just a random number that we generate. The other time we used a UUID. Maybe I'll use the UUID approach as well. Yeah. So I can, instead of doing this, that you can use anything as your index. So it's not a problem. So I have to import. Okay. So the embedding you use to list to make it into a list. And then the metadata, we just use text equals a document. So we are just doing this very simple implementation. Okay. So we create a function for storing that. So with this function, it becomes easy to store in DB. So the documents are the documents we already had, and then the embedding are the embeddings that we have just created from this embedding model encode, right? So, oh, by the way, one thing I forgot, after you have done these records, you will need to call pinecone index. So we already know the index. We can get the pinecone index by calling on PC dot index. So remember, we have already created the index, right? PC pinecone. So pinecone dot index. So if we go to pinecone, yeah, we call that index small dash rag. So this will be small dash rag. So that's just the index. So that gives us the instance of the index. And then we can now hold on, we need to index equals pinecone.index. Then we index.offset, and that's just it, right? Vectors equals records. So remember, when you're offsetting, the vectors has to be a list of records. So we already have all of these documents. So effectively, what we are doing here is that we are going through each document and the corresponding embeddings, which have been generated by the embedding model. And then we create a record for each of them, and then we append it to the list of records. And then for Pinecone, you have to provide an ID, which we generate, UUIDs. The UUID class allows us to generate IDs. And then once we do that, then the values would be the actual embedding vector, which we convert to a list, while the metadata will be the corresponding documents that come with it. Okay. So once you do that, then the next step would be um, how do we, so let me run this, right? So this is going to run. Oh yeah, I need to start from the beginning and run everything because I've added some new imports. As a matter of fact, I will move this import up. Okay. So yeah, there is something I forgot. So you need to create the Pinecone client instance, which I really did forget. Um, so we have to do that up here. All right. So first of all, you create the Pinecone PC, which is a Pinecone client equals Pinecone. So we create a new instance of Pinecone, or normally it's Pinecone dot Pinecone. So we create a new instance, and then we add the API key. So I am going to use os.getEnv here in this case to get the API key. That means I have to load this later on. I have to load my API keys later on. Of course, this also means I have to import OS as well. Okay. So I'm going to create Pinecone. So we'll create a new Pinecone client. It is a client that we could actually even create the index as well here. So we don't need to keep getting the index in the function since it's the same index, but we could also do it in the function as well. So whichever approach, it's okay. Um, so right, since I am at this point, let me quickly add my .m file, and then I can put in my environment variables. So I need to get the Pinecone key. I think I may have forgotten to save my API key, so I have to make a new one. Rag test. So I'm going to copy this. This time around, I'm going to keep it saved. Okay. So here I will just store, I have a whole bunch of environment variables here, which I just keep all of them in, just in case I need any of them. So of course, because I have brought in environment variables, I need to load .env as well. So import .env. So I need to load .env as well. Okay, so that allows me to create a Pinecone client with my Pinecone API key. I get a reference to the index I have already created. I created the index here manually. Um, you know, you can also create index, programmatically from the code, right? So, but in this case, I just do it from the UI and I give it the name small rag. So with this, I think everything is good to go. So let's run it again. Run all. So Pinecone is already installed. .env gets pulled in. By the way, when you load .env and you get it true, that means it saw a .env file and it has loaded it. Otherwise, it will give you a false. An embedding model is created. The documents are here. The embeddings are created. And okay, so this should be PC. It is the client that we're actually using to get the index. And yeah, so we have offset it. If I go now to Pinecone, you now see that the sentences I've added, the three of them have been added here. Okay, so we've stored our documents. Now, the next step, so we basically set up all the pieces that we need for our RAG, but it's not enough for you to store in the database. We also need to be able to retrieve. So when we are talking about retrieve, right? You have a query. This is a query that comes from a user, and then K is 2. So remember, K is kind of a measure of how many matching um, results you want to retrieve, right? So for Pinecone, it's called top K. So we can then query, we can then query, um, we can then query. So the thing is, first of all, the query comes in as a normal string. So we will use the embedding model to encode this query. And we have to put it in a list because remember, the embedding model works with lists, even though it could actually still work with a single string, if you go by the documentation that's shown here. Okay. So, yeah. So we have the query vector, which we call the embedding model. So remember, that's when we now want to retrieve. All we've done so far is setting up the vector database by using the embedding model to embed, the documents, each of them into embeddings. And then we put those embeddings along with the metadata, which basically matches with the documents. We put those in the vector database. We store it in the vector database. So that's the first part of it, which is storing. The second part is then retrieving. So for retrieving, you are still going to get a query, right? And when you get the query, you can now specify, the number of matches, how far you want to go, right? Top K. So the default is taken to be 2, right? Top K similar documents. Then we will first of all embed the query, the string that's passing as a query. So we still use the same embedding model. So again, remember, you have to use the same embedding model. If you use a different embedding model, you get a different response because it wouldn't match. Then you query the index, right? And then you specify the top K. So the top K would be K, right? Or I could just call this top K. So for the Pinecone database, you have to specify include metadata, of course, so that it will retrieve the metadata as well. And with that, right, what you will get back looks somewhat like this, right? It gives you, this is what it looks like. So we have to do a bit of cleaning on it. It looks like that. You get an ID, which is a UUID. You get a metadata, and then you get a score. All right. So, so retrieval will give you the matching documents. We don't want to do anything else. Like I'm not really interested in the score or the vector database. I can then just look through, which is what is done here. I can then just look through this, right? And return only what I need. So you see doc here has metadata text. So we can just do doc metadata text. So that's going to give you the text that matches it, right? So I forgot that you have to assign this to a thing. So this gives you the whole thing, right? So for each record, right, in the results that you get from the index query, which is this, you pick the record metadata and you pick the text in that record metadata, and that will give you what you're looking for. So that's retrieval. Now, after retrieval, the next thing is, so a good way to test this retrieval could be something like just retrieve. Um, so if you look at it, what we pass in here, the Nile is the longest river in Africa, right? Um, let's just mention Africa. Something about Africa, right? If we do this, our retrieval is going to retrieve, um, okay, I've missed something. So this usually happens if I mix up embeddings or something. But let's say I just pass this query in because encode normally should take either a list or an empty array. Well, this is in Pinecone. Pinecone API value error. Okay, let's try this again. Okay. Okay, so I think I know where I missed it. So the query vec, when you embed with the sentence array, it actually gives you, sorry, when you embed with sentence model, it gives you a NumPy ND array, right? It returns back a NumPy ND array, right? Or a list of tensors or tensor. Basically, it's a NumPy ND array. But Pinecone doesn't deal with NumPy ND array. So I had done it before, but I think I forgot that. So you have to do to list to convert the NumPy ND array back to a list. Otherwise, you have that failure. So that is what didn't happen. Okay. Um, right. So here, this has to do with my looping. Um, so I think I have to go through each of them. So it gives you a query. So it should be results matches. It actually gives me matches. So I think I missed that. It should be results dot matches. The results give you more other things in addition to the matches. So I needed to pick the matches and then run that. So with that, let me remove this other one, which I was using for debugging, and run it again. So we now get what we were looking for. So something about Africa, you can see that the two closest matches are this, right? So this is retrieval. Now, the next thing is we've done the retrieval, we've done the creating and storing. Now we've done retrieval. So now we need to do augmentation and generation. So the augmentation part, of course, is the generation of the query, right? So with that, we can just do a simple, um, we'll do a simple, you know, function that will manage the query. So we have the query, it comes in, and then we have the retrieved chunks, right? The retrieved chunks are the chunks that you retrieve from this retrieve function, and then generate answer. So essentially what we are doing is we are now creating some kind of prompt. First of all, we create a context, right, which is basically joining the sentences that we retrieved. And then we now create a prompt that tells the LLM, hey, look at what I have here. And based on what I have here, this is the query. This is the context. I'm sure some of us did this already when we were doing um the other assignment. Okay. This is the question. This is the context. So the answer will be based on the context above, you know. So I want to, yeah, um, based on the context provided above, generate an answer to the query, query above. So this is a very simple query that you would give to the LLM. Okay, so prompts. Put that in here. So let's say I want to use let me just use okay, I could use Open Router, I could use um Gemini. So let's see Gemini. So to use Gemini, let me write a separate function for that. Um, call Gemini. LLM and prompt. We don't need anything more than that. So, of course, first of all, we have to import, um, we have to first of all import Gen AI. Let me just put this here from Google Generative AI. Pro Gemini 2.5, Flash, maybe Flash or Flash Pro. Okay, and then um, we can then call the response, right? So we can then call model, which we have already created. So let's call this LLM model to avoid confusion with the embedding model, LLM model, generate content. We pass in the prompt, and then we return the response.text. Okay, so we can test this by just trying something like um, what is a rag? Let's try this. Just be sure we have everything. Okay, it's taking a bit of time. Well, so I'll let this run. While that is running. So what we now do here is basically we return the answer that Gemini provides to this prompt. So we can do a return Gemini, um, call Gemini LLM, call Gemini LLM, and we pass in this prompt. And that is basically a simple RAG. I'm going to run all of this, rerun the entire thing. Then we'll create a function that actually does the RAG, right? So the full RAG pipeline is made up of just um, retrieving the query based on this retrieve function, right? So you have this retrieve function, and it's going to, okay, I missed something. Oh yeah, that's correct. So it's based on this retrieve function. We will first of all retrieve the chunks that match this query, and then we'll pass this retrieved chunks along with the query into this generate answer, which is basically just something that um, a prompt that I have already put in place. And the prompt is going to essentially take the retrieved chunks as the context and we'll ask it. So you can always fine tune this prompt anyhow you like, but this is just an example. So once you do that, you return that. That is your full RAG pipeline. And you can just call it by saying, um, what is an what is an interesting thing about Africa? Okay, so let's see where we are failing. We are failing at some point. Um, Default credentials error, no API key. So I need to put a Google API key. Oh yeah, so I don't have a Google API key. What I do have is a Gemini API key, which seems to be missing. Okay, so let me put that back in. Oh yeah. Oh, okay. Um, I need to go look for it. I somehow lost my Gemini API key, so let me look for that quickly. Um, all right. So are there any questions on this for now? While I'm trying to get the um trying to get the Gemini API key. Are there any questions? Okay, so found it. Um, all right, so we can run this now. Oh, this should be Gemini API key. And must be missing something. Okay, Flash Pro. Let's try something. Maybe it's not getting my environment variable. Yeah, it's not getting this. Okay, so I need to reload .env. Okay, so this should be Gemini. Um, let's just do Flash. Flash, it looks like Flash Pro. We don't have Flash Pro. Yeah, so I should have just used Flash. Okay, so okay, so that's how you build it. So this runs. Um, I'm just testing it by asking what's a rag, and then it runs, and so we have the full rag pipeline. So with this, it's going to give me what I am asking for, right? So you can see without the augmented information, it probably would have told me something else, right? But because my context, my prompt was look at the context I'm giving to you and answer based on that context. So it's now talking about that it is home to the Nile River. Okay. So this is basically how you implement a RAG. Very simple implementation. Now we will go on and do the real deal. So I'm going to see if I can squeeze into about 30 minutes doing a full-blown fast API. So let's start off by going to my GitHub, into my GitHub account. I will do this online. I'm going to create a new repository. Um, I'm going to create a new repository. I'm going to call it AI for the RAG. Okay, so we'll create a code space. So I could create a code space so I can just do that in the code space. Okay, so the first thing we will need to do, this is fast API. So I'll need to create a fast API setup, right? And or maybe I should do it on VS Code because with VS Code I will not really be able to test it. But then I will not have a lot of time to test it. So let me just run with it, right? So let's start with a basic main file. So the main file is where, if you are doing fast API, you have a file called main.py, right? And that would be where you put everything. So I'm going to just dump everything in that single file and make it very easy. Now this time around, I could either use Pinecone or I could use the Facebook API. Okay, so yes, go ahead, Ngozi.
Please, sir, is this VS Code?
Yes,
Which platform is this?
it's actually a VS Code environment. It's called GitHub Code Spaces, right? So it's a way you can code online, and it goes directly to your GitHub repo, and it actually is built on top of VS Code. So you see that it looks similar to VS Code. So code spaces basically gives you what would, like um a VPS that allows you to do stuff like basically as if you are doing it in your own local host. Okay. So I'll first of all create a file and I'll just call it main.py. And I'm not going to do much more than that. Then I have all the imports here. So we have fast API import, we have all of this, right? So while I am coding, I'll also be installing all of the recommended extensions. So here, yes, they've asked if I want to, so I'm going to install recommended Python extension. Basically, code spaces runs on top of VS Code. Um, then I am going to install dependencies, right? So what are the dependencies? I need to install fast API first. So pip, I'm here. Okay, it doesn't look like I can do more than two things at once. So I have to wait for this to be done. So pip install fast API. I don't think I need to do a virtual environment, but let's just go with that. Okay, so it's asking if I want to create a local environment. Well, I'm not going to worry about this. Probably it's best to do that, like a virtual environment. So um Python dash m venv venv um yes, do I want to select it? Yes. Um source venv slash bin slash activate. Right, so we're in there. So we now say pip install fast API, fast API. Okay, so we have that installed now. So I have my main.py and so we also need to install pinecone and sentence transformers. So pip install pinecone and sentence transformers. Okay. So all dependencies, external dependencies have been installed. Then for the large language model, because I want to use Gemini, so I'm going to also install the Gemini dependency, which if you look at this, it's Google Generative AI. So this, I will install it by Google Dash Generative AI. I'll also install the .env. Okay, so um, I could do that. It's taking a bit of time. So, but I could do that in a separate tab. Hopefully that doesn't cause too much problems. So, or while that is going on, let's do our endpoints. Okay, so pinecone, sentence transformers, requests, right? Requests. Then there is this other interesting thing that that allows us to pass um it allows us to pass PDF files. So if I can import PDF2, PyPDF2 is a library that allows it allows us to, you know, um to import or to pass PDF files, right? So if I can import it, I'll use it. If not, well, I'll just mark it as none. Okay. So that's it. Then we can get a bunch of the let's get a bunch of API keys in. So we have that as configuration. So again, I'm going to bring this in very fast because of the time constraint. So first of all, we have a Pinecone API key, which will get it from the environment, right? Pinecone Of course, before this, we need to bring in .env. So um, I think we have that somewhere already. Um, okay, import .env. Then we can do um, .env.load .env. Okay, so this is it. Okay, so while all of this, so we have Pinecone API key, which will get it from here. Index name. So what we are using, remember, is small rag. Okay, now I'm going to create a new index for this, right? So let me create a new index. We can call this main rag or large or big rag. Well, big rag. And we will still go with the custom settings. I'm still going to use the same embedding. So it's going to be 384, just to be sure, 384. Now, okay, I'm going to change, right? I'm not going to use this. I'm going to use the larger one. Because if you want to do really big documents, it's a good idea to use it's a model, an embedding model that has a larger vector size. Okay. So yeah, let me look for the vector size for this. Um, I have to acknowledge the license. So I need to allow or accept the license so I can have access to it. Um, okay, so there's a whole bunch of stuff here. I have to read. Uh, I accept the terms. I always accept the terms, but I don't like to receive this. This is just going to spam me. Okay, so I am now having good access to it. I need to find out what size it is. It's a 300 parameter, 300 million parameter state of the art, but I need to know what is the size of the embedding. So you can see the input is a text string. The maximum input context length is 2048 tokens. Then the output embedding is 768, right? With smaller options available if you use Matryoshka representation learning. Well, we'll just go with a 768, right? And I'm assuming it's a dense embedding. It's a dense embedding model. So I will use this 768, 768. I'm going to bring that in here, 768. I'll still use a cosine similarity. Everything else looks good, so I'll just click on that. And while that is going on, so I will use that as the name, Big Rag as a name. So Big Rag, that's the name of the index. So then the embedding model, so is sentence transformers all mini LM. So I'm not going to use that. I'm using the Google Gemma. So I'll click here to copy that and I'll change this to Google Embedding Gemma. I'm not using OpenAI, so I'm not going to do this. Um I'm going to use Gemini. So I'll just use Gemini API key. So open Gemini API key. I'm not going to worry about the Gemini model. Data directory, so we just keep it in there, /data. That's going to be where we put in data. Chunk size. So we are going to talk about chunking here, and we're going to use a very simple chunking approach. Then So we'll talk about chunk size and chunk overlap later on when we get there. So let's just keep going. So this is set up now. We have this set up now. We have this. And I think all my pip stuff have installed. Let's see what else is left. Fast API doesn't seem to have picked it up. Um, so let's do pip freeze and at the same time just use this to make a requirement. Um, this bash window seems to be outdated, so I'm going to take it off. Pip, oh hold on, I need to switch to the virtual environment. Okay. Pip freeze and put in requirements dot txt. So let's just do that simply. So we'll have requirements dot txt here. So I'm going to see what we have. Um, probably don't really need all of this. Um, probably don't need all of this. Um, let me delete this. Instead, let's just install. Let's go to the virtual environment. I'm actually in the wrong environment. Um, source, VM, bin, activate. Okay. My, okay. Pip freeze. Let's see what pip freeze gives me in this case. Okay. Um, I don't know if I have fast API. I do have fast API, so I'm just surprised. Um, API. Okay, it's not used or it could not be resolved. Probably Pylons doesn't know where to find stuff. So pip install dot env. I think I already did pinecone sentence transformer. So let's now move to endpoints. Okay, so there are a bunch of things that we need to do first of all. We need to set up the directories. So this, right? We need to create the data directory, right? Um, ahead of time. So the data directory will hold the uploads, the files, PDF files, documents, that you want to upload, right? The okay, the original documents. Then we now create a new fast API. So we can just say I won't call it Pinecone. I'll just say demo rag API, right? So we will add course middleware. Of course, whenever you do fast API, you have to add a course middleware. In this case, I'm just going to allow everything so that I don't have difficulty with course. Then we will create the embedding model, right? And the embedding model is a sentence transformer, which we are getting from here. And we pass in the model name, which we have already gotten from the environment variable. By the way, that reminds me, I need to create a .m file. So I'm going to do that quickly. And then in this .m file, I need to put my Pinecone API key and the Gemini API key. So those are the ones that don't have default values. So let's see, I can do that real quick. Gemini API key, and then the Pinecone API key. Okay. Um, all right. So I'm not going to leave this on the screen for too long. Right. So Then next thing is, by the way, this is still running. So I need to install, I believe I've installed Pinecone, Sentence Transformer, Fast API. Let me just be sure. Pinecone, Sentence Transformer, Fast API. Um, yeah, .env. Um, yeah, so Google Gemini, I need to also install Google Gemini. So Google Gemini, where is Google Gemini? I need to find the name. So yeah, Google dot generative AI. Okay. So I need to um so those are all the libraries that need to be installed. So while that is running, we'll continue coding. So we will now, so let's create Pinecone clients. Okay. So this is also not a very difficult thing. We've seen it already, so I don't need to redo all of this. So we'll create a Pinecone client. We pass in the API key, which we already have initialized from here. Um, so we now look for if Pinecone name not in I dot name for I in P list indexes. So basically, this is just checking to be sure that we actually have that index. So if we don't have that index, then we create it, right? So this is a very nice way of like initializing. So if I've already created the index like I did from the UI, right? This doesn't happen. And so I just go ahead with it. But if I haven't created the index, then this condition will be true and we can programmatically create the index here, right? So, okay. All right. So I'm still having problems with Pylons, but that's okay. I'll look at that later on. Okay, so we've created a Pinecone DB and index. Let's just put them together in a bunch. Right. So after that, we start, let's talk about chunking, right? So chunking, chunking the text. So right now we assume that text comes in, right? And I'm just going to put in this chunking thing, right? We use what we call, this is a very simple, straightforward chunking, you know, algorithm. So for here, what you are doing is you basically um you have a while loop, right? So the way to think about this is, let's say you have, remember, chunking is a way to take a long, large document and you cut it into smaller um, pieces so that it can fit into your vector database. But apart from being able to fit, also fit into the context window of the LLM, but also in a way it helps to group really related information. So you don't mix the everything together. It makes the RAG to be smarter because it kind of zeroes in on what really matters. Okay. So that's what chunking does. And we say there are different kinds of chunking, like simple chunking. But in this case, we are doing a kind of simple chunking, right? But what we call with overlap, a simple chunking with overlap. So what's happening is that let's say you have um let's say you have, let me just draw an annotation here to help us with that. So um, let's say you have a large document like this, maybe a large PDF file that has a bunch of stuff on it. It's very long. Now, if you want to use this kind of chunking method that we are talking about with overlap, means that let's say you want to chunk 500, the size of each chunk is 500 tokens, right? Um, so you do 500. Then you now do an overlap. So the overlap means that the second chunk, let me use a different color. When I'm doing the second chunk, I'm not going to start at the end of the first chunk. Rather, I'm going to go back a few tokens backwards, right? To go and start from there to chunk the next, to cut off the next chunk, right? And then the third chunk will be the same thing, okay? Third chunk will be the same thing, right? So that's what this thing, that's why you are saying chunk overlap. Chunk overlap is basically saying when I'm taking the next chunk, how many tokens backwards do I go to start from? So that is what this is the approach, the chunking approach we are using now. So if you're looking at this code, right, you start off with an array of chunks. There's no chunk in there. You start off with the zeroth token, that is position 0 in your database. Then the length is the length of the text, the length of the entire document, right? So you now loop while the token you are currently chunking, the start point has not yet reached the length. You calculate the end. The end should be start plus size. So size should be the normal size of each chunk, right? So the end will be that. That's the size of that chunk. Or if the end goes beyond the length of the document, then it stops at the length. Then you take the chunk by just taking, start, end, and then you strip. Strip means remove white spaces at the ends. So if there is a chunk, you append that chunk to the list of chunks that we have, right? And that's a very simple thing, right? If there's no chunk, do nothing. Then on the other hand, the if the end gets to the length, that is basically we have reached the end of the document, right? Then we just stop, we break. So but if not, we continue. The next chunk, for us to continue the next chunk, we start the next chunk from the end minus overlap. So that's where the overlap matters, right? We start from the end and go backwards by the number of tokens that corresponds to the overlap. So go backwards. If the end minus overlap is greater than start. In other words, if we actually still have some text left, basically. But if not, the start should just be the end. So this is a very simple process to chunk the text. Now, when you chunk the text, then what's the next thing you do? We'll come to that. But we have a function here that will extract text from an uploaded document. So this is helper functions. These are actually helper functions that will help do a bunch of stuff, right? So the first one is to chunk the text. The second one is to extract the text from a file. So let's say you have uploaded the file, okay? So if you have uploaded the file, then what you have, the file name is what will be passed in. So the idea is that we want to extract the text from this file. So lower means file name.lower, you get the lowercase version of the file name. And if the file name ends with a .text or .md, in other words, an ordinary text file, or is an MD, MD is basically a markdown document, right? If it is either a text file or a markdown document, then what do? You just return the content. You decode it using UTF-8 decoding, right? But if it is not, then if it fails to decode using UTF-8 encoding, then you just decode using Latin 1 and you ignore error. So this is just a way of, okay, anyhow, we have to be able to decode and read the contents of the file. So that's for text files. But if it is not a text file, if it ends with .pdf, so it's a PDF file, you check if this PDF module that we talked about, if it exists. If it doesn't, then we will throw an exception and say, okay, we don't have a PyPDF2, which by the way, that reminds me, I need to do that. But if PDF, so that's an exception. So we'll basically stop at that point, right? Do nothing. And we're throwing a HTTP exception, a 500. So that would come back to the caller of the API as, okay, it has failed. But if there's PyPDF, then you use that, you create a PDF reader, and then you create a list that will contain all the text. A PDF reader from PyPDF actually reads it in pages. So you will now go through each page, right? For each page, you will see if you can extract the text for each page, right? If you can, then you append it to this text array, TXT array. If not, if it fails to read, you just append an empty string, right? And after that, you just return the /n dot join. So what this is doing basically is that it is taking the text and joining with um, line line feed basically. So it's going to do that. Now, so that's if it is PDF. So the third option is if it is a document that ends with docx, then we'll use a docx decoder, which comes, from so if we have it installed, good, we will use it. But if not, we'll throw an exception, right? And say, okay, we don't have Python docx. But if we do, we'll now create a docx document, right? And then we can, if the docx document succeeds, then we will just get all the paragraphs in the docx document and join it together with a new line. And that gives us what we want. Right. So that's it. So if it is not any of those, then we'll fall back to the last option, which is just, well, let's just decode the content with UTF-8, whatever it is, no problem. We'll decode it and we move on with our lives. So that is the function that will extract the text. So this allows us to extract text from either a PDF file, a docx file, or a regular markdown file. So those are the helpers. So now we go to the fast API endpoint. So we'll have the endpoints. Okay, so the first endpoint is to upload the file, right? So you always want to upload the file that will form the context. And I'm going to just do this. So to upload the file, you start with, of course, app.post slash upload. So of All right, so I had a bit of network challenge, but we are back. Um, okay, so I'm going to wait for my code spaces to load back up. Give me a thumbs up if you can hear me. Hello, can you hear me? Okay, great. Okay, so I was at the point where I was showing us this. So you have upload files, you have the file signature, the function signature here. So the files can come in as a list of files that you want to upload. And then the context will be additional optional context, right, for that file. So now, so that's the first thing. So if there is no context, then we will create a context. I guess this context is kind of an identifier to help us know, um, what context to connect this file to. Okay. So we will create a folder. So remember, we had already created a data directory up here. We had created a data directory. So the data directory we'll create a directory inside a data directory that has the same name as this context that we created. That is just to help us group files together. So if you want a file to be in the same context, basically in the same data directory. Okay. So this part of the code is going to basically create a folder. Um, so it looks like I lost some of the content, but it's not a problem. I think I'll just save this. Yeah, so this is one of the challenges of coding online. You need to have a very strong network connection. So, but while all of this is going on, we'll just keep going. Just keep going. Um, Yeah, this is yeah, so this is just a difference. It's okay. Um all right. So the whole essence of having a context and a context directory is it helps us to group things together, things that maybe we want them to be in the same context. This helps because like if you're building this kind of endpoint to service multiple usages or multiple uses or multiple users, you can use the context to differentiate between, these are files for maybe or multiple departments, right? These are the files for the legal department, these are the files for the um HR department and so on, right? So you don't bunch all the files into one place. So the context also helps, to kind of separate those, okay? So that's the whole essence of it. So we have we have the context directory, which we create by joining the data directory with the context that is created here. And then you make that directory, create that directory if it doesn't exist. Then you create a file directory, right? The file directory, create it inside the context directory, right? By joining the files, the name files. So the name of that directory will be files, and it will be inside the context directory, right? And then you also make that directory if it doesn't exist, okay? Then so that's still setting up where you want to upload the file. Then we will create the metadata path. So if we want to do metadata as well, you are going to create a metadata path by um, creating metadata.json inside the context directory. Okay. Then you create an empty file, sorry, an empty list, and you basically if the metadata path doesn't exist, right? Or rather, if it exists, okay, that means if the JSON file exists, you load it. So at least this is a way of storing existing metadata. So essentially, we're using the file system to persist previous things that we had done, right? But if this is the first time, then we don't bother about that, okay? So now we create new vectors. So new vectors would be new vectors for the new files that we are loading. So for F in files, so for each file that you have uploaded, you read the file content, okay? You read the entire file content. After reading it, you now call one of these helper functions to extract the text from that file. Remember, you have uploaded the file already. When you use upload file, it uploads the file. When you use this upload file um, type, right, for your files that are sent, right? So with this, you extract the text from the file, and then you use the other helper function to just chunk the text. So you chunk the text. Basically, you split it into chunks. So these chunks are now text, right? But you still need to do the embedding, right, for them. But of course, before we do the embedding, let's save the file because we want to keep track of it. So um, the, the interesting thing is that we are saving each chunk, right? We are saving each chunk, right? So this chunk, remember, if you go back to the chunk text, it's actually giving you um the chunk. What it's giving you is giving you a chunk and then the start position in the original text and the end position in the original text. So we will take that chunk, take the start and end position, right? These are now the chunked data, and we will oh, hold on, we need to save the file. So this is chunking. So we need to save the file first. So to save the file, the original file, not the chunks. Join file directory. So remember, we've already created this and with this file name. So we'll create a new, and then we'll save that. So we'll write the contents to that. So I'm trying to do this really quick. So I don't want to have to type out everything. Okay, so that saves the files, right? Then this saves the chunks and processes them. So processing the chunks in this case basically will mean embedding and then saving them in the vector database, right? So we already have a folder, a list rather that will contain all of the vectors. So we'll just accumulate it first of all, right? So to do that, we start with vector, we embed. So remember we've already created this embed model. So just encode the chunk and then convert it to list. So remember last time we saw that the embed model encode for sentence um, models will give you a NumPy array. So you need to change it to a standard Python list, which is what Pinecone will take. Then you create an ID, which last time we used UUID. So we'll use UUID as well to create UUID 4, version 4, right? And then we'll even take the hexadecimal form of it. Then we'll now create the metadata, which is basically the entire record that we want to store, right? So we use this ID, context. We'll remember the context. The context is where we have said, okay, this is a context. So if it is legal or whatever, we just use it to differentiate files. And it means that we can use this in multiple applications. Then we put in the file name, right? Then we put in the offset start, which is basically where the chunking started from. And then we put in the offset end. So you can see how this metadata becomes very important. And then we put in the actual chunk, that particular text, right? Okay. When we were doing the first example, we didn't do all of this because we were basically we didn't do any chunking. So we just put in text, right? And it was a simple thing, like I said. But now we kind of want to make this real world application. So we have to store, we are talking about files. So we have to store the files and all of that. And then, so you have offset start, we have offset end, and we have this text. Okay. Now, having done that, we'll now have new vectors. We'll now append this chunk that we are creating, um, this metadata, but we will use so this approach here is create this ID, create the vector embedding, the embedding vector, and then the metadata. And this is typically how you store in Pinecone. If you remember, you have to pass in these three, right? The ID, the vector, and the metadata. So you can put this tuple of three values either as a tuple, right? Pinecone accepts it either as a tuple or um as a dictionary. So we used the dictionary approach before in the other example. If you look at this example where we used the dictionary, so this is dictionary approach. We used ID, we use a dictionary, and then we use the values, which is the embedding, and then we use the metadata, right? But this is also using a tuple approach where I don't need to specify the names, but I know what is positional. So we create that. Then we also metadata.append. So this is also interesting because we want to keep a copy of the metadata locally. And this is it. So with this, we would have created vectors and records rather for each of the chunks, for each of the files. So when we have created the um, records for all of the files, then we will call the pinecone index and offset it into the pinecone index. So it's basically going to be index.offset, right? Okay, that's what we'll do, right? So we'll call index of offset, and then we will specify um, so I'll try this vectors equals new vectors, right? And after this, we'll also save the metadata. So to save the metadata, use JSON.dump metadata, metadata path, okay, for writing. So this allows us to just dump it into a file pointer. So basically are creating this, this is a file pointer, right? And we can just dump the metadata into that. And we specify indentation of 2, right? So with that, we can return this value back to the caller of this API endpoint. So you specify, right? So what we are specifying and sending back is um, the context and the number of chunks. Okay. So that's the first endpoint. The first endpoint is for me to upload stuff. Now the second endpoint is for me to do the actual RAG, right? And yeah, we because of the time, I'm just going to dump this here and walk us through the code. So so you have an endpoint, a post endpoint where somebody can call chat, where I will now chat with this based on the um based on the documents I have already uploaded. I have to specify the context. So remember the context was passed in. So if it is legal, for example, it means everything legal will be in there. So we want to ask questions in a legal context. So the first thing, of course, is going to be to create an embedding for the query. So you have the context, you have the query. So you create an embedding vector using the same embedding model. You encode the query, you convert it to a list. Then you do index.query on our pinecone index, right? The vector you pass in is this vector. Top K is 5, so we'll go with top K of 5. And then include metadata is true. Then this filter, so remember, Pinecone allows you to not just search by vector similarity, but you can also search by keyword. And in this case, we say the keyword is context. And we want the one that only matches this context that was provided. Remember, the context is one of the metadata you passed in. So when you pass a keyword like this in this filter thing, what it's basically doing is that it's going to check your metadata and only return the rows that match the context. That will be the first filter. Then it now uses the vector similarity check to pull the ones that match. So with that, you now see the retrieved values, the retrieved values um, remember, results matches, that gives you the retrieved values, right? So those retrieved values, you take metadata text. So remember, metadata, each of these is stored in metadata, then text is the actual chunk. So we're actually getting just the matching chunk. Then we assemble them, right? We join all of the matching chunks using line feed, okay? And then Yeah, so here I'm not going to use OpenAI. I'm going to use Gemini. So it's actually very easy. So let's first of all, um, so we have to set up Gemini already. So let's import from Google.generative import Gen AI. So we do that. Um, then we can set up Gemini here. Let me do that. Um, let me do that here. So set up set up Gemini. Now I'm just doing this to use Gemini, but a better approach would be for you to make it pluggable. So you can use any kind of, I don't need requests. So you can use any kind of LLM. So Gen AI dot um configure. So we're going to configure. Let me just take that straight from here. Um, so we will configure with API key, Gemini API key, which we already have. I assume I have that here. Yes, I do. I do. And then, yeah, we get the generative model. So, yeah, let me bring this down here. So we put it along with the other stuff, right? So LLM model. So we have two models. We have the embedding model and we have the LLM model, and we are just going with Gemini 2.5 Flash. Of course, this can be a parameter as well. Let me do that. So it's Gemini Gemini model LLM model name. So this should be LLM model name. So we can also get that from the environment. LLM model name. And the default value, we will go with the Gemini Flash. Um, okay. Let's change this also. Let's rename this to um embed embedding model name so we can differentiate between the two models names. So we have embedding model and LLM model. So embedding model name. Okay, right. So we've set up LLM model now. So when we want to do this, so we're not going to use the HTTP API call. Rather, we will just do Gen AI, and let's hope everything works. I should probably do some exception handling there, but let's just go straight in here. And so we have the prompt, right? We need to set up the prompt, right? Yeah, okay. So we have the prompt here. So this is a context, right? And um, I prefer to do this way. Ireland doesn't like this. Okay, that's a different problem. Okay. So so the context block is here, and then we have the question here. So we will now come and say answer succinctly. Let me just borrow what I took from the other place. What I did over here. What I did was in the prompt, where is the prompt? I basically said based on the context provided, generate an answer. So I will use that. Base generate an answer, a succinct answer to the query above. Okay. Then we will complete this. Oh, yeah. Okay. I prefer this so I don't have issues. Okay. So we will now not do this, but just take our response from LLM model, generate content with this prompt, and we can do try an exception handling, but um so answer is, oh, this should actually be response of text, and context is a retrieve context, which we already retrieved here. So, and that is the endpoint. So we have a third endpoint here where you can view all the context and all the metadata. So those ones are not really important, but well, they are already there. So let me just add them here. That just loads all the context, and then this just allows you to load metadata for any given context. And with that, we have basically done a complete endpoint that does everything, right? So I could actually do this. So I need to install UVCon. I probably um may not be able to. Oh, I'm sorry. I need to source VM being activate. So okay, so I have UVCon. So let's see what happens if I say UVCon um main main dot main app, right? Probably I don't this is the first time I'm using code spaces, by the way, so maybe it might work, maybe it might not. But yeah, this is it. Okay, so we did not get this Google.generative pip install Google-generative. Okay, so I need to figure out what we do to install that. Yes, this is all backend. Even the RAG with JavaScript is going to be backend as well. I need to figure out what is the pip name. Okay, so I'll find that out in a second. Oh, okay, I think I missed something. Yeah, it's actually Google Generative AI. Yes, that was my bad. Let me be sure. It's Google Generative. Yeah, so it's Google Generative AI. So this should actually be Google dash Generative AI. AI, right? Uh, okay, so we can now run UVCon again. And right. So UVCon is running. I'm just testing this to be sure that all my imports are okay. Cannot import name chain I. Okay. I probably misspelled something again. Okay, import as. So yeah, I'm not yeah, it's not from import as. Oh yeah. Okay, right. The good news is that Pylance is lying to me, so all of these things are getting um they're actually working out pretty well. All right, so I don't have access to embedding Gemma 300M. Um, I need to be sure. Oh, I need to have the Hugging Face. I need to have the Hugging Face API key. That's the problem. So yes, I did not add the Hugging Face API key. So let me do that quickly. Uh, Hugging Face API key should be in here. And I believe that should just work because sentence transformer, Hugging Face just looks for that HF API key in the environment. So I put it in there and that should just work. So let's see how that goes. Okay, so it says it's a gated repo. Hmm. Okay, so it does mean that I have to look for another one. Um, or maybe if I do that, I will need to change my, let's go back to using the previous one, but I will need to I'll need to drop the sorry, um models sentence transformers. Let's use the one we've been using right before because we don't have time to investigate that issue. But it does mean that this index, I will have to delete this index, the big rag. So I'm going to delete it. And I'll now test my code by ensuring that big rag will actually, remember I have a place here where I try to see if I can create the index if it didn't exist. And you can see the dimension is 384. Well, so that's interesting. This is 384. So it was obviously already configured for the sentence transformers. So again, I'm going to now run UVCon again. So we keep trying this just to make sure it runs. And right, so this works. Okay, so we have another problem here. Python missing one required positional argument spec. Okay. Um, okay, I need to check that. Um, create index. I will have to check Pinecode documentation for creating index. Let's see. API PC sample. They had some sample code here. Um, yeah, but they don't have a create index here. Oh. Um, let's look at their docs and look for create index. I've not done it before, so maybe that's why. Okay, creating an index. Yes, this is what we're looking for. So, create index for model, um, create index. So you would have to, okay, right. Um, I guess I'll just take all of this. So let's just take that and let's see what I'm missing. Obviously, I'm missing something that has become maybe a required parameter, a required argument. So, index name, we already have that. Vector type is dense. Metric is cosine dimension. I have that. Metric is cosine. I have that. Spec is serverless spec. Um, yeah, so I need to import serverless spec from Pinecone. So maybe I assume we will have serverless spec. Um, let's be sure. Okay, so we import it from Pinecone, and so that's okay now. So let's run this again. Okay, so the question I will be asking now is, how do I access this endpoint? Let's see if Unicon goes all the way to the end. Okay, I need to install Python multipart. I need that for Fast API. I'm surprised that Fast API didn't install that along with the others as a dependency. Right. Finally, we have liftoff and application running on port 8000 available. So how do I access this? Code Spaces should be able to give me access. Okay, so this is how I get it, right? Fluffy Halibut. Is that how I get it? Um, oh yeah. So what I would like to know is how do I connect to this with a with Postman or with UVCon. So and Fast API I can do right. I don't know if this is a thing, but it's probably not the thing. I probably won't have access to it, right? With code spaces. But the good news is that this is running, so I will pause at this point. I'm going to save this and I'm going to give everyone a link to this repo so you can go try it out. And I'm going to try it myself. What I was hoping to do was to upload a document and then use it to do some interesting, neat stuff. I might actually do that on a VPS I have just to show everyone how it works, or to do it on localhost. So so that's it. That's it. We have successfully, but I need to figure out, give me a second. Let me see if I can figure out how to connect into this. Okay, that's interesting. Oh, I could actually control click this. That's what I have been told. I can control click this and it takes me there. Right. Interesting. So let's do a bit of stuff, docs. Um, so this is it, right? Um, something is missing. We should have two post endpoints, but we only have one. So I've missed something. Let's see. App.post upload. Okay, there you go. I made a mistake. So this should be at app.post. So we missed that. Okay, so I have to stop UVicon and restart. And we should have that. So what I'll do is I'll look for a document, upload it, and you can just ask questions. Let me refresh this and see if I have. So I have upload. So I can upload a document now. Try it out. I can choose a file. Let's see. What do I have? Do I have? Um, okay. Um, so I have chosen a um. So tech. So let me call this tech entry level. So this is a document that is a PDF. I just uploaded it, right? So by the way, um just for context, I'll maybe I'll show you the document I uploaded. It's a PDF. It's let me see if I can open this document here. Right. So this is the document. It is basically a presentation I made about entry levels tech skills for experienced people. So I'm just going to test this by asking a few questions based on this and say what are the top paying tech jobs? What are the top paying tech jobs? And how much do they pay? This is the document I uploaded, right? And the upload is successful. Okay. Oh, but I have an error. It says PYPDF2 is not installed. Let me see if I can do that quickly. Um, I forgot that I didn't do that. So forgot that I didn't do that. So it's actually quite easy to install that. So let me stop UVicon and install it again. Pip install PYPDF2. The other thing I should have installed is the document one. So we can also try out documents. So let's see docx. So I need to install this as well. So let me see. Python docx. Good. So we have all of that. Then I'm going to start UVicon again. And so this is the document. It's a PDF. I want to see how good RAG is. Right. Okay. So UVicon is still running. We'll soon be done. Okay, UVicon is running now. So I'm going to refresh this. Um, right. So let's try that again. Um, try it out. I'm going to choose a file. So the same file, applying tech entry level. So that's the document. Um, entry level. Let's see if our PDF library reads it properly. So the fact that this is running for so long means it's been able to take that file, it's been able to, process it. It's probably calling the embedding um, model now. Um, it's a pretty long file. So yeah, it's done. And what we got is a 200. So success, right? 16 chunks. Nice. So then the context is tech entry level. So when I want to now do my chat, I will use this same context. So I can now go to the chat endpoint and try it out. So the context, I put this, and then I'll ask a question about this thing. So take note, this is the slide this is the document I uploaded. I can now ask a question. What are the top paying tech jobs and how much, right? So let's do that. What are the top paying tech jobs and how much? This will now go to Gemini, right? Hopefully Gemini API key works, which we just tested. And okay, so we get an internal server error. So let's check here. Ubicon should tell me what the problem is. I knew it was going to be a Gemini problem. So it says I should set the Google API key. So let's do that quickly. I called it Gemini API key. So let me just call it Google API key. Um, Let me even see how I set up Gemini in the first place. Um, I think there was a problem when I'm setting up Gemini, Gen AI. Okay, I didn't specify. Let's see what I did here. Here, what did I use? I still use Gemini API key.
Hello, sir.
Um, yes.
Yes, sir. I think there is a misspelling
Okay.
somewhere
I need
at
to
that
configure this. At where I'm configuring it, right? Let me see.
where you
Uh,
created the variable. Yes, Jenny is what you wrote. Where you were loading the environment, the os.environment.
okay.
No,
I think
sir.
that is correct. Yeah.
Okay, you've correct. This one, is it?
No,
Okay, maybe it's me
this
that
is
is
what it
seeing. Okay,
was.
I'm seeing it as N.
Gen
Okay,
AI
sorry.
dot configure. Yeah. Uh, so let's use a different thing. Others were using environ.get, right? So these other ones are using. Oh, I'm sorry. That's the problem is I did this before I did the load, before I loaded .env. So .env did not see it, right? I should have done this after loading .env because the .env file does not get activated until you load .env. So let's do it let's do it here. So that's why I missed that. So I need to I need to restart UVCon. So but the upload is fine, right? Because I used the sentence transform and sentence transform was probably properly set up. So now that this is back up, I can really just do the same. I can just rerun this again and click on execute. And let's see what it gives to us. Right. So you can see it gives me an answer. The answer is based on the context provided. Here are the tech jobs listed with their salaries from highest to lowest. DevOps engineer, 126454. And if you check that, you see DevOps engineer, 126. Can you see this, right? Um, Software engineer, 109020, right? Information security analyst, 102600. And it gives you look at the context. I could ask a question like, still in the same context, I could say, okay, um, what job would you suggest an entry level tech person to focus on, right? So um, you see, based on the context, several roles are listed as best entry level tech jobs. A help desk support technician is explicitly mentioned within this list as a potential entry level role. So if you go and check that, you see entry level. I don't know whether there is help desk technician, but I probably found it, right? Um, give me 5 tech skills for experienced people. What are considered advanced level tech skills? So let's try that one. Um, what are considered advanced level tech skills? So you see, according to the text, advanced level tech skills include programming languages, web development, mobile app development, data analysis, and data science, cloud computing, cybersecurity, DevOps. So if you look at advanced tech, you know, it mentioned all of those. So what are the 4 opportunities for beginners? Mention opportunities for beginners. What are the opportunities for beginners mentioned? Let me ask that. What are the opportunities for beginners? I'll try something interesting like asking you to summarize. Valuable opportunities for beginners include internships and apprenticeships to gain hands-on experience. So it just came up with this first one. Probably that is the only summary or the only match. Okay, summarize the document. Let me just see what comes from that. I don't know what the RAG comes up with, though. You know, what the retrieval comes up with. So this document from the camp boot camps encourages in the camp. I don't know. To pursue a taker, highlighting its high demand, diverse opportunity. So you see the context. See, this decamp is because in the chunking, we have chopped off KodeCamp here. So we chopped off the KO. So it now becomes the camp boot camps, right? So this is one of the things when when we do this simple chunking, it's a problem. You see, it has just split a word. And because of that, the LLM is now saying this document from the camp boot camps, right? So that's why the best form of chunking is the semantic chunking, where you are chopping it off at paragraphs. Because if I was chopping it off at paragraphs, I would not have this decamp. This is actually code camp that has been chopped off. So um, this is also a very good look at this, like this other context, right? This D gets chopped off, right? The rest of the sentence or the rest of the word gets chopped off. So in a real world thing, right, you would use what do you call it? Semantic chunking. So what I'll give to everyone as a task after this is send me a PR on this repo and implement semantic chunking. And let's see if yours does better. So I'll end the class at this point. And yay, I did a RAG in less than 3 hours. Thank you very much, everyone, for staying up till now. And let me stop the recording.